In general, if you look at this, we've got prisms and cylinders and cones and pyramids. But it's on the front, it's surface area. Surface area is actually the harder of the two. You guys notice that? And then on the back is volumes. So, yeah, I'll say this again for the camera. We will go through and talk about all the formulas. You guys, you and I will like brainstorm. What are the formulas for these? Then probably after 20 or 30 minutes, we'll go back and talk about the odds. See if you got them right or not. Okay. Let's start with the general formulas, and then we'll be more specific for each problem, like what we should plug in. So, in general, how do we find start with the hard one, surface area. I'm going to make a little chart table here. How do we do surface area of cylinder, prisms? The very basic formula we used is 2 base areas plus the lateral area. And actually, let me change that. For the lateral area, we used perimeter of the base times the height of the cylinder. Okay. This is like the first lesson in the chapter. It's probably the hardest also. That's funny. All right. Anyway, cylinders. Well, it's 2 base areas, but what are the base areas? Circles. So it's 2 pi r squared. Plus, instead of perimeter, it's circumference. 2r pi times the height. That's as specific as you can get on cylinders. Prisms, we can get more specific based on what the base is. It's going to change our formula a little bit. Okay, volume. How do we find the volume of the prisms? Area of the base times the height. How do we find the volume of a cylinder?
Base times height.
Area of the base, but the base is a circle, times the height. Okay. You got those in your notes. Let's scroll this way. I guess I could just do this. Pyramids. So this would include everything we've done except for the spheres from yesterday. Alright, how do we find the surface area of a pyramid? Area of the base plus 1/2 perimeter slant height. Slant height, because pyramids have are slanted going up on the lateral. And cones are, the area of the base is pi r squared. Whoops, what the heck am I doing? Plus, the lateral surface area was pi r L. Pi r slant height. And then for the pyramid volume, it was almost the same as the prism volume, except for what? You guys remember?
Square.
There was 1/3 on the front. So you had to divide by 3. And then on the cones, it's like the cone volume, except for you had to divide by, or it's like the cylinder volume, except for you had to divide by 3. So all right. Now, let's go through each of these and talk about the formulas. Then you guys can go back later and plug stuff in, and, you know. Let me read the directions. Find the surface area of the figure, round your answers to the nearest hundredth if necessary. What's a hundredth mean? Second decimal place. Leave your answers in terms of pi for answers that contain pi. So on the circular answers, like the number 9, the cone, that'd be the only circular answer on this page, wouldn't it? Number 9 should have a pi answer, basically. Okay, number 1 is a what?
Number 1, that's a prism.
It's a pyramid.
Dude, it looks like a prism.
So, pyramids, here it is area of the base plus 1/2 perimeter times slant height. How would we find the area of this base? Right.
I saw touch sheets, and they came back up solid.
So, we can replace the formula with the area of the base with little base times little height divided by 2. Triangle area. Plus 1/2 times perimeter times slant height. So what would the perimeter on number 1 be? Perimeter of the base? 21. 7 times 3 is the perimeter of the base. And then the slant, what's the slant height on number 1?
6.1.
So 12.2, yes.
That's what that is?
Yeah.
You
6.1.
were you here for this day? I don't remember.
No.
And what would the, let's go ahead and talk about this, I guess. What would the base of the, base times height for the triangle, what would the base of the triangle be? The triangular base.
7.
Triangular base is base, yes, 7. And what would the height of the triangle be?
12.2.
No, that's the slant height of the
Oh, so I don't know. Only it
6.
tells us, right?
6.1.
How is that the height?
Of the triangle base, not the
Oh.
capital H, not the height of the whole thing, it's the height of the,
The baby one.
yeah, the baby height. Okay. That was number 1, my word. Okay,
You have to do it with us.
number 2, I kinda already did.
You don't do it.
Did everything but the, how would we find, okay, 2 is a what?
2? That's a
What?
pyramid.
It's a, no, gosh,
Is that
Oh.
a prism?
it's a prism, hexagonal prism,
How is
right?
that not a pyramid? It looks like a pyramid.
Pyramids come up to a point.
Bro, if you ask an Egyptian what that was, they would say pyramid.
Okay, are you looking at
Oh,
number
I'm
3?
looking at 3. Looking at 3. That's my bad.
Yeah.
I thought we were doing the,
I was like, what are you talking about?
Okay, number 2 is a hexagonal prism, so
I'm sorry.
it's one of these
I
things.
didn't read it.
How do we find the area of the base on this one?
You do the apostrophe thing, right?
1/2 apothem perimeter. So instead of 2 times area of the base, it's 2 times 1/2 apothem perimeter plus perimeter of the base times height. Okay, so you can be a little more specific than this if you know what the base is. You guys know what I'm saying?
Yeah.
Picking up on. So it's the same thing as this. I just replaced the base area with an actual formula.
Okay.
Okay, number 3. Yes, it is a pyramid. The Egyptians all agree. So, just use the pyramid formula, or the, pyramid. How would we find the area of the base on number 3?
You do 10 times 10.
10 times 10. So you could replace the b right here with like 10 squared. 10 times 10. Number 4. Which side of number 4, or which sides are the base of number 4? Or,
Which sides are the base?
yeah. No. Okay, Number 4 is a triangular prism. The triangles are the bases because on prisms, the two sides that are identical are the bases, like number 2. So usually we don't draw it like sitting on one side. Usually we draw it where the triangles are on the bottom or whatever, kind of like number 2 is a hexagonal prism. But those triangles are the bases. So how would I find the area of one of those triangular bases? I kind of look at it carefully. If you look at it carefully, it's basically 3, 4, 5, right? How would I find the area of this triangle? Right, 4 times 3 divided by 2. So 6. But there's 2 of those bases, plus we have to do the perimeter of that base times the height. What's the perimeter of this base? 12. And what's the height of the prism? It's not in this picture. This is the base, not the what's the height of the prism? Can you guys tell from the picture?
3, right? Oh wait.
No, 3 is this thing. So remember, the triangle is like the base, so that's like the bottom. No, 4 is like the base of the 2. Yeah. If you lay it down on the triangle, the 2 goes up and down. I know. I'm talking to everybody, not just you. All right, so times 2. We ended up kind of doing the whole thing on that one. That was kind of tricky because it's standing up instead of like lying on its base. Anyway, number 5 is pretty much identical to number 3. So I'm going to skip that one. You don't skip it though.
What's the L thing again?
Slant height. It means, so the height of the pyramid on number 3 is not drawn because it would have to go straight up from the ground. But the slant height is used to find the lateral area. Anyways. Number 6 is another pyramid, but the base of the pyramid is a hexagon. So you have to do 1/2 apothem perimeter for the base area. And then the lateral area, so much. Well, instead of 1/2, well, yeah, just use the 1/2 perimeter slant height thing.
Which one's that 6?
Yeah. The area of the base, I just was more specific than base plus 1/2 perimeter slant height. The area of the base is a regular polygon, so 1/2 apothem perimeter. Okay, number 7.
That's a prism.
Looks like, yeah, it's a rectangular prism. So how would I find the area of the base?
You do 7 times 5.
7 times 4. Little base times little height. Like of the, when it's little b, little h, that means the base of the rectangle, not the base of the entire prism. You guys remember talking about this?
Kind of, yeah.
For the rectangle on the bottom, this is its base, this is its height. But for the base of the entire prism, it doesn't really look quite like this. The entire rectangle would be the base of the prism, so that would be a capital B. But for the base of that rectangle, that's a little b. So this is a base, and this whole thing is a base. Just depends if you're talking about the rectangle or the prism. They should have came up with different words, but they didn't. Sorry, okay. So base times height here is referring to the base and height of the rectangle. Okay, that's the 2 base areas. And then the lateral area, remember, is perimeter times height. number 8 would be the same as what?
6.
Number 6. Number 9. Okay, it's cylinder formula. I'm not gonna write it down again. We already wrote it down once, so. On number 10, we talked you could do the same thing as 7, but there's kind of a special thing on cubes. What would the area of one side of number 10 be? What would the area of one side on number 10 be?
16.
16. How many sides does a cube have? 6. So you can just do 16 times 6 on that one, instead of using the whole prism formula.
You say you can?
Yeah, that's what I would do, yeah. That just works on cubes though, because all the sides are the same. Okay, the back. This is easier because the directions say the same thing except for finding volume, rounded to hundredths if necessary. Use pi if there's pi. So, pyramids, 1/3 area of the base times the height, right? But the area of the base on number 11, it's a regular pentagon, so for the area of the base, you can use 1/2 apothem perimeter. Right? Number 12, same thing. Number 13, same thing. Number 14, same thing. Number 15, same thing. Actually, I lied.
Why?
Number 12 and 15 are triangles, but they aren't. So we can't use the... Don't lie. So for the area of the base, like on number 12, how could we find the area of that base?
8 times 6. Oh wait, no, not like that.
Area.
Yeah,
8 times 6.
8 times 6 divided by 2. So since it's a triangle, base times height divided by 2. If 6 is the base, 8 could be your height from the triangle. There's a 1/3 and the height.
Oh, never mind.
Well,
Never mind.
sometimes they do draw in the apothem of the triangle, but they did not do that on 12 and 15. For 15, it's a 3, 4, 5 triangle, just like we did on the front for number 4. So you do like 3 times 4 divided by 2 for the base. Okay, how would we find the volume on 16?
You do
For prisms, it's area of the base times the height. How do we find the area of the base?
2 times 2.
2 times 2 times the height, 2. So cubes are really easy. It's just 2 times 2 times 2. Cube volumes especially. 19, almost identical to 16. For prism volumes, the area of the base, 2 times 5. You do that times the height of the prism, so 2 times 5 times 9. But on 17, the area of the base is a regular pentagon. So you have to use the 1/2 apothem perimeter times height. 18 is a cylinder, so you have to use pi r squared times height. Talked about that one already. And then 20, looks like the base of that triangle is 9, and the height of the triangle is 2.6. You divide that by 2, and then do that times the height of the prism. So in general, it's area of the base times the height. But on all those pyramids, you do have to multiply by 1/3. Looks like they put all the pyramids together though, so 11 through 15, those are the only 1/3 problems. And then 16 through 20 do not use 1/3.
16 through 20 though?
Yeah, so 11 through 15, and if they threw a cone in there, it'd be the same thing. All those formulas for volumes of pyramids have a 1/3 on it, and a cone would have a 1/3 on it. but everything after that, 16 through 20, those are prisms, so there is no 1/3 on their formulas. It's just base area of the base times the height for all 5 of those. But on 11 through 15, it's area of the base times the height times 1/3. All right, lots of formulas, aren't there? Quite a mess. So why don't you guys try that? We'll check the odds just to make sure you're on the right track, but show your work. I'll be mean and not give you credit.